Okay, I want to talk about this week's lab. So it says in Sketch, include library, manage libraries, install the MCCI LoRaWAN LMIC library by IBM and Terry Moore. So we're in this lab, we're going to go from the base LoRa and try and connect up to the Things Network backend. There is another one that says something like LMIC LoRaWAN library, and if you look at it, it says it's been deprecated and to go use this library. This library is up to, I think, version 4.01, but there's some issues with some of the later versions of the library with the Heltec board. I haven't quite figured out why exactly that is. And so version 2.31, it all works and fine. It seems that some of the later versions of the library seem to make it so that it's supposed to whenever you say a certain delay amount, it go and pause for that, but it keeps sending even when it's not supposed to, and it's kind of spamming the Things network. And I'm not really sure why that is going on. But version 2.31 does work. So when you go default, it'll say 4 point whatever. Make sure you install this version of the library. And so we go and install MCCI LoRaWAN LMIC, again, version 2.21. A couple other libraries we're going to need that are in the sample, or some of it. I want you to install the Cayenne low power payload library, and that is not in there, and you're going to have to add that as part of it. And it's Cayenne, the LPP has a published set of data. So there's a certain code to send temperature. There's a certain code to send humidity. There's a certain code to send blood pressure. There's all of these different things. And so if you say I'm sending it in this LPP protocol, the receiving end and the Things network knows what the LPP protocol is. And when you send it that code, it will go, hey, you have its temperature or its humidity or its blood pressure or what have you. That's what LPP is about. Otherwise, you have to send it just in the actual bytes, and then you decode it all. But I want you to use LPP. And again, so when we bring in that library, it's not there in the example code. The DHT sensor library is there. And in fact, the example we're going to do is the one to do with reading the DHT 22, which is what you have, or actually, you might have the DHT 11. I have to look. It'll respond to either. And so it says Arduino library for DHT 11, DHT 22, and similar temperature sensors. And I've seen some people have shown me the little blue cross-hatched part from your Kuman kits from the 130 course. Some people have the little DHT 11 just by itself, and some people have it on a little board with the 10K pull-up. And so if you don't have it on a board, you need a 10K between data and your VCC in order to be able to properly read out your information. So that's what's on the little board. You might also, there are similar ones. DHT11 is got a different timing characteristic from the DHT 22. DHT 22 tends to be a little bit more accurate, and you also have something known as an AM2302. That's a DHT 22 as well. I think yours is a DHT 11. You just have to get that right because the timing's different to say it. And then it says open the TTN OTAA Feather US 915 DHT 22 example from the MCCI LoRaWAN folder. And so if we go, and so if you look, there's an MCCI LoRaWAN LMIC, and there's a TTN OTAA Feather and it says 915 DHT22. We're running at 915 megahertz, and so we want to have that example. And there's also OTAA, and there's also something known as APB. The way things pretty much now are over-the-air authorization, and that's what we're doing. And so there was a previous way of doing things that was more common in the beginning, which is ABP, and you had to have network and session keys, and you don't have to have that for the OTAA. The OTAA, when you go and hook up, it negotiates session keys at that time, and so it's considered more secure, and that seems the way things are going with it. Okay, so that's the example that we've got, and then I'll open one up in a few minutes and we'll have a look at that. So once you have that and those libraries installed, then I need you to set up a Things Network account. And so you go over the Things Network. It was I think they have commercial options and things now. I think if you are going to do something just small scale, it counts one of 50 devices when I go and set up. So I think for free, they'll give you up to 50 devices, and then they'll hope that you'll help support everything and be part of the one of the commercial options. So you have to sign up, get an account. There's my account there. And then you go to what's called the console. And in the console, you need to set up an application and a device. And so again, we talked about an application. I have an application called Pizza Trucks, and then I have a LoRa module in each pizza truck, and each one of those is a device for my application. I can then say I want freight delivery is another application, and I have a bunch of devices under freight delivery, so I can segment that all off. So there's an application identification on the LoRaWAN backend, and there's also a device, and we need to know what those are and input them so that when our LoRa devices connect to a gateway, it goes to the back end and it gets to your application, and it's AES encrypted from your device to your application. Okay, and so we need to do that. So I said, as far as an application goes, that I am here. Okay, and so I wanted, as far as the lab goes, you to have an application ID with ESET260 and your first name, and then application name. That's just going to be to help you remember what it was about. And I just said ESET260 demo app. That doesn't really matter. The application ID is we're going to be looking at, and you could have added a description, and you just say then create an application. Okay, and then once I've created an application, it shows here ESET260 demo app, and then we look down, and over on the left I have overview, end devices, live data, payload, all of this kind of thing here. And I could either import devices or add an end device. And I don't have any devices right now, so I'm going to need to add an end device, and that's going to be your Heltec module. And so you add an end device, and then I can either click on the previous one, there was a button over here, or you click on end devices over here and just add an end device. And this stuff you want to get frequency plan. There's a bunch of different frequencies in around 900 megahertz, and you'll see one says used by the Things Network. That's the one we want. So select that we're used by the Things Network. And it says LoRaWAN version, and it's way above MAC-V 1.01, but just put it on 1.01 right now. That's keeping compatible with all our things. I haven't tried it on the later versions, but depends on the libraries that where the MCCI group. Later versions of the libraries might be needed for that. This just is all left alone. And then we have, it says dev EUI, and this is where it says 1 of 50. It never used to give you a limit kind of thing on here. So that's where I think for one account, we're now limited to 50 devices in a non-paid for format. And so a dev UI, now you can generate one, just click generate and it'll make up some UUID, or you can type one in. And I made my dev UI, I just typed that in for an ID, and it doesn't really matter. Like I say, you can generate it. And then an app UI, and it says fill with zeros. And so this is something new from the last go rounds where you have an app end unit identifier and a dev unit identifier, and it goes fill with zeros. I don't, I like putting something in, and I took mine just from the last one. But again, you could make up something here as long as it was, 8 hex values here stuck in. And so whatever we put in there, we're going to need to match up with our Heltec device. And so we'll go and look at what we have in here, and then we'll make it match up. And then for this app key, we need to just hit generate, and it'll generate this big number for us, okay? And so again, that's all going to be unique stuff. And then it says end unit identifier. Once I've registered the device, it goes EUI dash, and that's just my dev EUI that is sitting there. And sometimes you'll see reference to that. And it goes view registered end device. So you just go register end device. And then typically, then I'm going to take these values and I'm going to have a look at them, and I'll fire it up in the screen, and we're going to need to put it in our code. Okay, those 3 values that you get there. Now, I want to go to over here to payload formatters. And by default, it says none, and I want you to go to Cayenne LPP. And again, that's a protocol, and where we're saying, okay, if I give you certain values, then you will know it's temperature, or you'll know it's what have you. And in fact, if it's temperature, it might say the next byte is going to be temperature, or the next 2 bytes. If I say humidity, it might be the next byte. If it's either a GPS coordinates, it might say the next 6 bytes are GPS coordinates, and there's a certain format. And if the sender and receiver knows that, then when the data stream's coming in, I can decode it properly and map it and all of that kind of thing. And that, like I say, there is a published Cayenne LPP protocol that you can go and look at. Okay, so it says under integrations, then, so we've done the payload formatter, and now I want integrations. And so what integrations does is it says, okay, you've got the data, and we could have stopped just there, and my device will send it to the things network. Now I want to know how I can get some data back. We've already looked at MQT. There happens to be an MQTT integration, so that's awesome. So when you go and set it up and just say, hey, I want to use MQTT, it will automatically show this stuff. Now, when you clicked your account to generate, it said there were Australia and somewhere else and somewhere up in North America. And so we picked the North America backend server endpoint. And so that's saying North America Cloud to Things Network on port 1883. So that's the closest one. That's the one I set my console up to. Doesn't matter where or what gateway, if it's on the back end of the Things Network, it'll route it to that back end in North America, and then come and decode my application. So the NAM1 Cloud, the Things Network stuff, I want to know that when I go and set that part of this lab up. So that's there. I can go look at it under MQTT integrations. It says, what's a secure socket layer address? So this is a public address, and that's also if I'm sending like encrypted data, secure socket layer type data. So it's just a different port address. But this is the one I'm going to be using right now. And then it says, hey, what's your username? So it generated it for me, and I called myself ESET260mel. So it says ESET260mel at TTN is my login, okay, whenever I have MQTT. So before we went to the Hive MQTT server, and it was public, and we just said, we're anonymous user, just click anonymous user and just connect up. Now we actually have to have a password and login to be able to connect up, because they don't want just anybody sending data to the different topics or getting information back out. Now, what you will see is it will say, have a little generate button, okay? And when you go generate, it'll make this long password, okay? And so, and it says, copy it somewhere, because I won't tell it to you again. And so you need to copy it and stick it somewhere, because you need it when we go and do our Node-RED stuff for the password to be able to hook up to it, but it won't be there anymore. You'll have to delete it and add another key or something. So copy this down, and then as soon as you click OK, it's gone, but it will give you an opportunity. There's the little cut and paste symbol to go stick it somewhere else. It gives you a shortened version of it as a, hey, remember when you set this key up, but it's not enough to be able to make it work for the password. It's just saying this was one of your keys, okay? And so you keep this thing, and then we'll go look at what we do now. So that should be everything all set up on that end of things. Okay, and then it says generate and save an API key and save a copy of your key somewhere. So that's going, it'll do the similar kind of thing. And so what I've done here is, if you forget or you need to add another key, there's an API keys. And this is kind of cool in that I set up here another key, and I said, here is, see, here's a key ID, whatever that is. It's a shortened form. And I said MQTT read and upload key. Now, by default, and what you did on the other side, it just grants all current and future rights. But you can also say, you know what, it's a little node MCU. I don't want it to have to be able to create devices or delete an application. Delete your application, that's your pizza truck application. You don't want one end device to be able to have that kind of power. And so you say, okay, I'm going to give you an API key that just is able to view devices, maybe view keys, link applications to a network server, read uplink and write downlink, read application traffic and write application traffic, and that's all I want. So you can specify that you have, maybe you have a device that only writes information, or grabs your downlink information, or you might want just to be able to something to be able to just read and not be able to write, for instance. And so you can set all of these rights, and that's kind of what's one of the new things in this new version is a lot more thought in the security end of things. So you could have your devices out there, and even if somebody compromised that device and was able to come out with your API key, well, this thing only reads it, so that's all it can do anyway, kind of thing, depending on what you set up. Okay, and there's integrations. We used MQTT, but there's connecting up to Amazon. There's connecting up to Microsoft Azure. There's another place called Alora Cloud. So there's all of these different ways of getting out there. Now it says update the connections to your SX1276, the device EUI, application EUI, app key for your TTN device in your code. We'll have to go and look at some of that. And every 1 minute, send your temperature and humidity to your application and device on the Things network in the Cayenne LPP format. Set up widgets for temperature and humidity in Node-RED and display your sensor data over MQTT. So I want you to send data up to the cloud, and then I want you to bring the data back. And we talked about that being in the, it's in Node-RED by itself, but it requires a bunch of things being set up, not that it's a big deal. or you can just use the ST monitor because it had it there, and I'll show you how we do it in there. So I want you to set up the widgets for temperature and humidity and display your sensor data over MQTT. And then by the end of the week 14, I want you to demo the device overview on the Things Network showing your connection. So there's my demo app, and then it's showing there's ESET 260mel, and there's the uplink data. And then I want to see the widgets displaying on Node-RED. So there's the data on our Node-RED dashboard. There's temperature, humidity. I fired in a temperature graph going there. And then I want you to send your name to your LoRa device. I mentioned one of the cool things about our LoRa device is that when it sends data, then there is a window. In fact, there's 2 download windows, opportunities to send data back down to it. And the typical thing that you would use is the next time your device, for instance, wakes up and send something to the your application in the Things Network, then I could have sitting there for it some instructions. Maybe, you know what, I was having you wake up once an hour. Now I want you to wake up once every 10 minutes. So I could send you an instruction, and then you would take that, your device would take that, and then start waking up more often. So I want some ability to be able to do that kind of thing. And you can do that with this download window. And in the Things Network where we have that available to us. And it says submit a screenshot of each to the D2L Lab 13 assignments folder. And so that's the last lab. It involves a little bit. One of the things, just so I'm not going to trip over this, so there's basically your screen with the Things Network, that Things Network stuff I showed you. That's Node-RED on the Raspberry Pi. You guys are using Raspberry Pis next term. So that's just Node-RED, how to install a dashboard because it's not installed by default. You have to go and do that. And then it's just saying, okay, on this screen, which you can wire up in SPI, your screens on this and have a little display if you wanted to, kind of thing. So we'll talk about that in the Raspberry Pi time. So your screens will still be useful. Can't get a lot of information on there, although I can get the whole desktop. Whole desktop shows up, although it's kind of tiny. But you know, you'll see stuff on the web where people, you know, make little game machines and, you know, retro game things and stuff with that. But that's just showing all our Node-RED stuff, and it auto boots up to that screen. So that's what it'll do just when I have it all plugged in. Okay. I just disconnected my network, so I didn't bother trying to, it supports Wi-Fi, but I didn't bother trying to make it do any of that kind of stuff and try to get through the college's system. All right, I want to open up, let's go there, and let's go to tools. Oh, that takes a while. Okay, so we have this example, and it's TTN over-the-air Feather US 915. That's the we're using over-the-air instead of having individual session keys. It makes new ones. We have a DHT temperature sensor. Mine is a DH22. We have to look and see what yours is. I can't remember. Might be 11, it might be 22. They're the blue ones. It would say on the little pack in the front. What does on the oh, DHT11 on the back. 11? Okay, so all you have to do is change yours to DHT11. That's important. Like I say, the timing is different. And then there's a bunch of stuff here. If you just try and go and compile it, it will give you an error because it says there's an error, fill me in, which is a hint to you to say you got to fill stuff in. And the things that you have to fill in is here it says this EUI must be in little endian format, so least significant byte. First, when copying an EUI from the TTN control, it means to reverse the bytes. For TTN issued EUIs, the last bytes should be D5B370. There's D5B370. So some of that I'm going, okay, what does all of this mean exactly? And so if we go there, when we go and hooked up, again, we had Europe, we had North America, we have Australia, we have Legacy, which is shutting down December 1st, so don't go there. So we go North America, and that was that NAM one we saw. And so I've already logged in. And so, again, I have some of the gateways. We are using the gateways that are up there, so we could go and look at those, but we're going to look over at our applications. And I've got two applications. I've got ESP8266 temperature sensors. That's a temperature sensor that's up in my office. And then I've got this ESET260 MEL. And so that's my application, and I should have individual devices under there. And again, I had that, I said that it was a demo app over here. And then so we have this, and we see some data that is going by. And it says last activity was 33 seconds ago. And so this is a unit that is sitting, and here's the end unit. They used to give you, you could call them by names, but with this version now, it's just the number, and they put EUI dash whatever the number was that I picked for the dev EUI. So there it is there. And I said the name of it, I called it Heltec LoRa, and there it's got some of the information. And so if I click on this one end device that I have here, it says, okay, here's app EUI, dev EUI, and there's an app key. App EUI, dev EUI, app key. Okay, these two say little endian format, and this one says just big endian. Okay, and so what I do over here is I look at this and I say, oh, that's great. So I'm just going to copy that out. But let me go notepad. That's not going to work for me. It's going to be one big number that I can't kind of use. So instead here, what I'll do is I'll click this, and it'll turn it into a bunch of comma separated hex values that I can put into an array. That's awesome. The only thing is, we went and did that. It says MSB. I need it to be LSB. So now when I copy it over, now I've got it LSB, and the last was D5B370, and that kind of matches up. It should be D5B370, so you know you've got it right. The most common thing that I've seen go wrong is people getting the numbers back to front or all of this kind of thing, and then just nothing works, okay? So dev EUI, same thing. I have to reverse it. Oops, not that one. So dev EUI, once again, I do that. And again, I switch it over to copy it. And then the app key, we can just copy it out. And so, but once again, you know, I need to be able to, if I, where is it here? Go there, and then I can go there and turn it into that kind of format. Okay, and I don't swap that one because that's MSB. It says MSB, and copy that one in. So I copy all three in, and that means your board should now have all the keys it needs to be able to talk to your application. And it uses the keys here to encrypt the data and then securely log on and then decrypt over on the other side. Okay, so that's that. Then it says we're going to send the payload to the Things Network Gateway, schedule a transmission this many seconds, 30 seconds. You could change it to 60 seconds, for instance. Here's another thing that's a little different, and I will, well, it's on the video here. The default settings for everything is not what the health tech board is. This is LMIC, which is that library, is being told what the chip select line is, what the receive transmit. Some boards share transmit receive and switch back and forth on the single antenna, and this doesn't need to, it deals with everything all internal. So it's an unused pin. The reset is on reset LoRa, DIO is DI0, 1, and 2. I just renamed all of those in it to the things that is defined in the pins in the Arduino library, so that it was make it more sense to, and each one of these actually goes to individual pin numbers. But I had to go looking on the schematic for where it is, and so when we looked at the Heltec LoRa pin map, it talks about what pins the different LoRa bits are on. Okay, and so we need to map that over. So by default, yours will not properly talk to your board. You need to remap this. Okay, and then it makes an instance with the right type, and then it goes through a bunch of the different scanning. And then when it negotiates network and session keys, again, you used to be able to log in that way. You still kind of can, but it's discouraged. It will just print out what it got for that setting. And then you go through here and it's got a bunch of transmit. And then when you go down, we'll go down to start. And it says, okay, wait 5 seconds for things to go. I set to 1:15.2 to be able to go and look at what data is going on. The DHT begin, that's part of the example, to be able to make it go. Cayenne, if you bring in Cayenne, needs an LPP reset to start out Cayenne. And then it says initialize the LMIC. And that's all part of the example. It sets up the band and all of that, and then it's going to send out the job. The loop, you have to keep really, really short. It needs to keep running this loop to be able to test for incoming, to be able to send outgoing. And so if you do anything more than a few milliseconds in here, then you're probably going to not get good transmissions. But we don't really, most of the things are handled with events. And so what we have is up here, we have this send job, and it says, okay, if there's not a current transmit receive running, then we read the temperature from the temperature sensor, we add the temperature, and then we print out the temperature on our local console, and then it will read the humidity and then set that up, and then it says divides it up into individual bytes. So I've got an integer. I need to put it into a high and low bytes, little endian first. And then it says prepare to transmit. And so it will transmit it by calling LMIC send data this buffer that it has. And so it will send the data out. And then what I want you to do is put it in this kind of Cayenne LPP mode. So you will, instead of putting it in we'll have a separate buffer for the Cayenne stuff that we'll send it out to. Okay, so we've got that. Hopefully you will have everything compile, and if you do, you should see it show up on your network. So you should see data starting to go here. Now, if the data isn't in the right format or whatever, you might not see it. For instance, in here, let me go to live data. In here, live data. So in here, because I have LPP and I said it was in that mode and I was sending it in that mode, then it automatically knows what relative humidity is and it knows what temperature is. And the actual bytes that are getting sent is 01, and then we have 67, and then 00E9. So this is the first thing that's sent. 6700 is humidity. Then we have E9, and then 02 is the second one, and then we have 6862 being sent to talk about our temperature. And so all of that is, if you go Cayenne LPP protocol. Now, it has the LPP library that you brought in has things like add temperature, add humidity, all of that kind of thing. And it says, okay, include Cayenne LPP. And then it says, okay, LPP reset, which we did. There's functions like LPP add temperature, add barometric pressure, add GPS. And it shows you kind of samples of the data it's expecting to see. So if I go add temperature, this is the first thing, this is the second thing, this is the third thing I'm going to send out. And if I want temperature, then I stick it in there. And you see it says Cayenne LPP, set aside 51 bytes for a potential long packet. We're not, that's the maximum you can do. We're not necessarily sending that out here, but I have an LPP reset over in my setup, for instance, and then just where you saw in the code where it got the temperature, then you could go LPP add temperature and add the temperature. Then where it said pressure, or sorry, humidity, LPP add humidity. You just need to say, this is the first thing I'm sending, this is the second thing I'm sending, for instance, and send the right thing. And then instead of then, once we have this buffer, then you're just going to, instead of sending what we just did over here, where instead of sending we send this buffer. And so this is what by default it was sending payload, and we're just going to this one line. Once you add temperature and add humidity and all the rest, that will send out that data. And then when you decode it in your things network, then you'll automatically see this stuff coming out. So if you get this far, then that's saying your device is connecting to our gateway. So if you're at home and you're not near a gateway, it's not going to work, right? You have to be close to our gateway. And so it's sitting in 204. And so you should be 204, 205, 229, 227. It should work in any kind of those labs. I haven't tried it down here through all the concrete and all of that kind of thing. So you should be able to then see that you're getting a bunch of data. And so the other thing that we have is you have the ability to look at messaging. And so in messaging, I have uplink. So simulate uplink, that was useful last year because the gateway wouldn't let your devices we had to register them with the network in order to make any data. So this simulate uplink wouldn't do anything until your device saw the gateway. So what was happening is everybody was stuck at home, and I would get you would send me your dev keys and app keys. I would put them in my unit because I've got a gateway at home. And as soon as my device registered a real unit with the server, then you guys could simulate uplink. So just set the payload set for whatever you want, and it would go and treat it just like it's a real device. So right now that I'm live, and so, it said last activity 10 seconds ago, if I disconnected even, I could go in the payload and simulate that guy was there. And it would go, okay, it's kind of like your real device sent you data. It can't do it until your real device connects up at the first time. Now on downlink, what we can do is we can say, hey, I'm going to send some bytes. And so I'm going to go send, 30, 31, 32, 33, 34. So that would be ASCII 0, 1, 2, 3, 4. Okay, and so I will schedule that in the downlink, and then let me go to live data, and there is it's scheduled 30, 31, 32, 33, 34. Now, it didn't decode it because I didn't put it in that LPP format. I couldn't go 0, 1 and say I am 6700, whatever, and say that's humidity and send it, and it would properly say, oh, that's humidity and all the rest. Now, what it did is it downloaded it, that it sent that to my Heltec device, which is at my house. Okay, and on screen, I could print out. I didn't ask you guys to do that this time, but on screen, it could print that out. So when it saw it. But the idea kind of is, other than to show that you could get stuff sent down, is you could easily get that and print it out on a serial monitor to prove that it was there. But the idea is you could change sleep mode. You could send something to say, now I want you to forget about temperature and just give me humidity. Or now I want you to look at something else. And so you can schedule that. And it's just a matter of putting it in the downlink. The next time it connects up, you're talking to your device somewhere. And then it goes to sleep for a month, kind of thing. So that's kind of a neat part of that. Okay, so when we have all of this going, then it's just a matter of, and you can just log in and look at your data, but I want you to put it in a more graphical format. We're going to use the Node-RED instance for that. And so you're going to start off with, if I can find it here, our, what is it, STM cube monitor. And we don't have enough time to finish talking about this today. We'll continue on with it next day. So to begin with, you have your basic flow, okay? And so what I can do is I can click this plus and make another tab. In fact, there's another tab there, and that's TB217, which has in my office. I can click another tab, and we're going to instead over here, I'm going to call that Heltec. And so I've got a Heltec tab. And so here we see Heltec, we see TB217, all that, and that's over in info on this tab. And I'm just going to make that kind of disappear. So they're there, but they're faded out. They're not actually involved right now. It'll just be this Heltec one that we're going to look at. And we're going to start off by looking through to see what kind of things I need. And the thing I need to grab is going to be our MQTT. And so there's a bunch of dashboard stuff there. This you have to install if you're doing Node-RED. You would have to, the full install of Node-RED or put it on a Raspberry Pi, you have to install that. And then I'm going to deal with MQTT in, and we'll go and look through some of that. So next day, I will go in, we'll step by step, we'll go through and we'll grab some of the data from the site and be able to push it up. It's fairly, there's a bunch of little pieces, but it's fairly straightforward to make it do it. And we can check it with our debugging features along the way and see if we're getting what we need to get. Okay, so we'll do that next day. Hopefully everybody will get data pushed up in this week's lab, and we'll go from there. Thanks.